Hi class. I'm going to do a quick introduction to using Cantera on CADEM as an alternative to GasEQ. You need to have some familiarity with using the probably the terminal, although that's not essential. And you can find tutorials for that online. There's also a good tutorial at BYU's Fulton Supercomputing Center. If you click on the Documents tab, there's a Unix tutorial, which is quite good and take about an hour or two of your time if you're interested in taking a tutorial like that. You'll need to use this under Linux. So if you're in the CADEM lab, you can just log in on Windows, and then on the Start menu under the Programs, there's Internet Programs, and then you'd click the SAM client and log in under the RGS Linux side of things. I've done that just directly through a terminal. I'm running Bash right now on the left and a Matlab code on the right. One of the first things that you need to do is in your home directory, your J drive, there's a file called bashrc, and you'll know that you're running bash if you see a little $sign at the end of your prompt. So if I go and look at my .bashrc file, those are the contents of it. At the very bottom, this line would need to go in your bashrc file. Source /groups/CHEN633 setup Cantera.sh. That'll connect your system to all the paths where Cantera is at. And if you edit that file, then anytime you open up a terminal, then that'll already be set. You can check by typing env pipe grep path. Well, we'll just go echo $path, and you can see these these Cantera that are in my working path, so it knows where to look to find files. So all you have to do is add that to the bottom of your bashrc file. Everything is in the groups folder. So if I go to groups /CHEN633, and I'll add you guys so that you'll have CHEN633 as your group, you'll notice that that setup Cantera file is right here, setup Cantera.sh. If you go to Cantera_codes, you'll see a file called eq2.m. That's an equilibrium solver that I've just modified. This is going to be a Matlab file. So over in Matlab, you basically are going to type eq2, and it's going to run all the commands that are seen here on the left. So you'll need some familiarity with Matlab if you want to edit these files. I have some good Matlab tutorials as well. And here you can see the code is set up to do equilibrium for methane air, essentially, across the full range of mixture fraction. And I'm plotting temperature on the top and then some species mass fractions on the bottom. So that was all you need to do is go to MATLAB and type eq2, and it's going to run all these commands. So let me take you through very briefly what these commands are. Clear clears all the variables in MATLAB, and cleanup just basically to start everything fresh. G is an object that's going to hold, this is the Cantera object, and it's going to hold all of our functions for our gases that we're going to equilibrate. We import phase here, gas.cti. There's a gas.cti file in your directory. You can see it right, where is it? There, gas.cti, and you can edit it directly if you want. It's going to equilibrate among all of these species. So you can see the GRI30 right here, GRI30. When we look at our eq2.m, it's doing GRI30. Okay, so if you want to change species that it equilibrates among, you'll have to edit this list of species, just delete them or add them. So you might want to make a backup to this file. I should note that you shouldn't do anything in the Cantera codes directory. You'll want to copy that to your own working space, because this is shared among everyone, so I don't want anybody to edit it except for me or if you have permissions. So anyway, we can change that. If you look at EQ2, we have the gas. Here you're going to specify the species that you want. ICH4, O2, and N2, those are indexes in the species list. So in that mechanism, if we look gas.cti, CH4 is down here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So if we look at ICH4, it should be 14. Okay. And we do that for O2 and N2. That's just so that we can set the species in the list of all the species. Okay, NSP, we grab the number of species. So you can see we're going to call a function called nSpecies and pass it G to that function. YStream0 is going to be initialized to zeros. It's an array of size NSP by 1. It's just a vector of all the species in stream 0, and we have all the species in stream 1. So stream 0 is going to be basically air, O2 and N2, and stream 1 is going to be your fuel mixture. You can add whatever you want to it. The number of mixture fraction bins I want to do, here I'm using 70, and then I make an array of all the mixture fractions that goes from 0 to 1 with 70 bins. Okay. Then here I'm specifying my reactants, product mass fractions, product mole fractions, the temperature of the products, the enthalpy of the products, and the density and mean molecular weight of the products. You can add lots of other functions here if you want to record different kinds of things. Here I just have a for loop over all the mixture fractions, and I'm basically just setting the mass fractions of the reactants at each mixture fraction. And you saw this same equation in class. It's just a linear relationship between the stream composition and the mixture fraction. And then we do our main loop. So we're going to loop over every mixture fraction, and we're going to set the gas to have the following temperature, pressure, and reactant composition, a different reactant composition for each point through the for loop. And then we're going to do an equilibration. So HP stands for enthalpy pressure. So this would be adiabatic at constant pressure. And it already knows what the enthalpy is, because if you set the temperature, pressure, and composition, you've set everything else. Okay. There are other functions for setting the gas in more general ways, like you can set the composition, set the temperature, set the pressure, set the enthalpy, etc. But this is a nice little function to set everything at once. So it's equilibrated. Now the G object, the gas, contains the equilibrated products. So now we can store those by calling the function mass fractions of the gas, and it will store them in the products. And temperature of the products, calling temperature, and enthalpy of the products, enthalpy mass, density, molecular weight, mole fractions. Okay? And then anything you want you can interrogate from this gas object. Then here I'm plotting it. I stored some things I wanted to plot, all the species I wanted to plot. So CH4, O2, N2, and then I grab the species index for CO2, H2O, etc. Then I make two plots and plot them up. Now, you don't have to plot it. If you wanted to, you could save it to a file. You can see here I also stored the mean molecular weight, even though I'm not plotting it. So in Matlab, if I just type M, it'll show me the molecular weights that I stored. If I type xprod, it'll give me the whole big array of all the species at every mixture fraction. I can do the same thing for like hprod, will tell me the enthalpies of all the species. So it works pretty well. To see what some of the functions are that are available, you can type methods solution -full. And all of these are options that you can call. These are functions that you can call, which is really handy. So if you want to set the mole fractions, if you want to grab the species indices, if you want a list of species names, if you want the thermal conductivity or the viscosity, if you want the, I don't know, C sub V on a mole basis, on a mass basis, etc. You can use those. You can find out more about them with helps. You can type, for instance, help sound speed, sound speed, tells you what it gives you in the units. Help temperature gives you the temperature. Okay, so we can do a temperature of the gas, and it gives us our current temperature. Okay, pretty straightforward. There's lots of other help available. If you look up one directory from Cantera codes, there's Cantera tutorials, And these are worth learning. You've got 1, 2, 3, 4, 5, 6, 7. You have to have a little MATLAB background, but if you have some MATLAB background, then you can look at these, star.n, and you can basically run them directly and you can read through them to see how the code works. Okay, and they teach you a pretty good introduction. This is pretty powerful because it gives you a whole toolbox within a MATLAB environment to do all kinds of different calculations with gases. And you can write different kinds of reactors and solve very complicated systems with these functions. And it has this nice MATLAB interface which helps a lot. So I hope this gives you a little bit of a background. You can edit the file directly and it might help you a little bit with your homework. Let's see if we have equilibrate in these things. So you can see all these some of these tutorials talk about equilibrate, and you can see TP, constant temperature and pressure, HP. You can do internal energy and volume. So you have several different kinds of problem types that you can use with the equilibrate function, and this just shows you how to do it. Let me know if you have any questions or if this is useful. This is kind of a nice alternative to GAS-EQ, but it's a little bit more involved. And so you can see that. But for the most part, it's just going to be a matter of codes EQ2. You can edit this. You don't have to edit it in a terminal. You can edit it in whatever your favorite editor is. It's just a text file. Edit it and then tell MATLAB to run it. But in MATLAB, of course, you got to be in the directory where it's at, Cantera codes or wherever you put it. If you copy this Cantera codes directory to your own space, then you tell MATLAB to go there, and then just run EQ2. Let's see. But basically, it's ready to go. It will output for methane. You can change the composition of the streams here. These are mass fractions, not mole fractions, over here. So you'd want to edit that. To be the corresponding mass fractions, or you could set it up with the right functions to do it in terms of mole fractions if you like. But if you wanted to add more species, you could do that. If you wanted to change the compositions, you could just give it a new gas file where you change the number of species that are in the list. And it's a pretty slick program. We use a C++ interface to this code in my research all the time. And it works great. It gives you a library of all things gas phase, chemical kinetics, and others. You can do a lot of different kinds of things with this. Cantera has been used for aqueous equilibrium, for vapor deposition, lots of different kinds of applications. So I will leave you with that, and let me know if you have any interest and if you have any questions. Thanks.